All right, so if we sketch some graphs, we can do these by hand just by looking at the equation. So we look at this and we see that A is equal to 4. That means it's greater than 0. B is equal to 5. So again, A is greater than 0 and our B was greater than 1. So we should know that this is going to be a graph that crosses the y-axis at 4, and then it's going to have to increase through that point since B is greater than 1. So it'll increase through that point. Start low and then hit that point and continue up. Not a great sketch, but again, it's just a sketch. Okay, in our second example then, over here, we have A is negative 10 and B is 3/4. So A this time is less than 0. So that tells us it's going to be below the x-axis. And B is between 0 and 1. So that tells us that it's going to do the opposite of what we think. So let's sketch our graph. We have our graph here. Let's put our negative 10 down there as our intercept. So 0, negative 10 on the y-axis, or our y-intercept. And I'm going to do these by 2s. So 2, 4, 6, 8, negative 10. And there's my y-intercept. B is between 0 and 1, so it should, I would think it would be decreasing, but it's below the x-axis, so I know that it has to increase through that graph, or through that point. So I'm going to start below my negative 10, come up through it, and then continue on increasing. And I have an increasing graph. Let's look at some characteristics now of graphs. The x-intercept. Well, with an x-intercept, we can say that there are no x-intercepts. If you look at those graphs carefully, if we put like an increasing graph in here, b greater than 1, a greater than 0, we can see that this graph goes forever and ever left and right, but it never crosses the x-axis. If we take a look at a graph in our calculator here, 2 times 2 to the x. And then we do a standard window and we look at the graph. It looks very much like my sketch, but you can see that it never crosses the x-axis. It never gets below that x-axis. And if I look at my calculator and I continue to go up and up and up and up, when I get into those, they're just getting closer and closer to 0, but it never becomes 0. So we have no x-intercepts on exponential graphs that are general. Let's talk about the y-intercept then. The y-intercept, remember that we said that that was the a, and the point would be 0, a. In our equation, we could find the y-intercept as that constant a. So let's look at our graph. We said it was 2 times 2, and the 2 in front, that was my a, and it was 0, 2, we just saw in our table, was the point that we had. Now let's think about the domain. How far to the left and how far to the right is this graph going to go? This is my sketch of my graph. And this graph is going to go forever left and forever to the right. So we can say that the domain is going to be all reals. Let's think about the range values then. Remember that we don't have an x-intercept. So that means that we never quite get down to y equals 0, but it increases from above that x-axis. So we would say that y is greater than 0. Or if we put it in interval notation, we'd have to say 0 with a parenthesis to infinity, because we can't include the 0. Okay, the horizontal asymptote. The horizontal asymptote, remember, is that asymptotes are imaginary lines that the graph tends toward but never crosses. Well, we've already discussed that this graph gets real close to the y-axis but never crosses it. So our horizontal asymptote would be that y equals 0, or the x-axis. And then if we look at this particular graph, talking about increasing or decreasing, as b is greater than 1 in this case, so it's increasing. If b would be between 0 and 1, that's when the y values are getting smaller as x values get larger. So let's look at a final example. We want to look at the specific graph, and we want to know if f of x is increasing or decreasing. And we can look over here as x is increasing, we can see that the y values are also increasing. So this is an increasing function. Now, is this considered exponential growth or decay? Well, if we think about in real life situations, if something is getting bigger and bigger and bigger, it's a growth. If it's getting smaller and smaller and smaller, we call it a decay. So we would call this one an exponential growth. Now, if I use my graph to estimate for f of 1, this is an x in here. So I go to 1 on the x value and go and see until I hit my graph, and it looks like it's approximately across from the 9. So I'm going to say approximately 9. Now I want to use the graph to find x when f of x is equal to 1. Well, that's this y, or this 1 is a y value. We'll change colors here. So I go to 1 on the y and go across until I hit my graph, and it's kind of hard to tell exactly, but I'm going to say that it looks like x is about 1. It's approximate again, and it's equal to -1 now. So if vertical intercept, that's easy. That's right there on the graph. We can see that one, no problem. We know that that one is 0, 3. So now we need to write a possible equation for f of x. Well, remember that the y-intercept is our a, so a in this case is going to be equal to 3. So now we at least know that f of x is equal to 3 times something. We have to figure out what that something is. We know that b is greater than 1 because we're increasing here, and if f of x is equal to 1 when x was 9, that meant that it was 3 times 3 to the first. So I think the base is going to be 3 times 3, so we'll say 3 times 3 to the x. And that would be my function.